afternoon, and welcome to the September edition of the Self-Build Hour. I'm Jenny Chandola. I'll be your host today. I'm an architect with AC Architects, as well as the host of today's hour. So as we've explained in the past, we've put together this Self-Build Hour in an effort to bring self-build tips on a particular topic to you in the comfort of your own home. For those of you who are joining us live, you'll have the additional benefit of being able to ask questions. We ask you to do that via the Q&A section or the chat section. Q&A is preferred, but I understand some people do not have Q&A. And I would like to then also tell you that today's topic is on heating. So a lot of you will have questions about heating. What is the right system? Even what are the systems? And there's often confusion about the different parts and components that make up a heating system. So today we're really pleased to be joined by Louise Randall. She's the business development manager for Zender Group, and she helps individuals and businesses implement really effective, efficient indoor climate solutions. She knows a huge amount about the different heating options that are available on the market, some of which you're going to be familiar with and some may be very new to you. When I first met Louise, I was really impressed with her passion for recommending the best fit solution for each project that she comes across. So I hope you'll join me today and welcome her as today's expert on heating your home. With that, I will let you take it away, Louise.
Thanks very much, Jenny. I will just move you guys to the left a little bit and start sharing my screen. Bear with me 1 second. Hopefully you can all see.
Yeah, that's great. I can see that.
Perfect.
Thanks.
So I'll start by telling you a little bit about us, Zender as a company. We are a Swiss-German-owned company. We have over 4,000 employees, 16 production plants. We're present in 70 countries and a sort of estimated 600 million euro turnover annually. We actually started in the 1800s. In the 1920s, we were actually manufacturing light motorcycles. From the manufacturer of the motorcycles, they realized that they could actually manufacture steel tube radiators. Our Charleston radiator is called Charleston radiator because it was started to be manufactured in 1930s and the dance was very, very popular then. We invented the towel warmer. Unfortunately, we didn't patent it at the time, which led to lots of copies coming into the marketplace. And then through strategic mergers and acquisitions, Greenwood joined us in 2006, which has led to sort of the development of the MVHR ventilation products and Caladair, which is quite a new acquisition for us. We have 2 sites in the UK. We have a production facility in Lenham in Kent. They're experts in plastic moulding and assembling some of the smaller MVHR units. And we have a head office in Camberley in Surrey. We do also have a stand at the Self-Build Centre in Swindon. So if you are heading that way, do stop by and have a look at what we've got on display there. But I'll jump right into heating so that we don't labour on the point too much. 2/3 of energy required by private households is used for heating. The way in which we live and work has changed very significantly in recent years. COVID seems a bit of a distant memory now, but it has changed the pattern of working. A lot more people work from home. And in doing so, obviously have to heat their properties for much longer periods of time, where we might have had our thermostat set to just come on when we were actually in the house. We're spending more and more time at home. When we talk about heating, it really is a thermal comfort that we're trying to achieve. Because it's very subjective. What's comfortable for me is not comfortable for somebody else. So it's really what is your your ideal thermal comfort. Insulation will always be the cheapest form of heating. If we fail to insulate our properties correctly, it's just like opening all the doors and windows and letting that heat escape through the fabric of the building. In turn, the better that we insulate our building, the more requirement there is for ventilation, because obviously the more we ventilate, the more we insulate. We're keeping all that moisture, all those harmful indoor air quality markers inside the property. So we really do need to ventilate. So it has to be a joined up strategy. But obviously a fabric first approach is the key to reducing energy consumption. And in doing so, we also need a system that is really quick to respond, because we don't want to overheat our properties. So, as Jenny rightly says, every project is completely unique. Their requirements can be very, very different. Choices you can make based on your own personal preference, could be on the aesthetics or based on function, but sometimes compromises do have to be made, because what looks pretty doesn't always do the job. So, you know, making sure that that equipment is actually fit for purpose is really, really important. So unless your property is incredibly thermally efficient, sort of passive house levels, you will need some sort of thermostatically controlled heating. The only exemptions for these are properties that require less than 10 watts per square metre. They're exempt from a thermostatically controlled system, but those properties are quite few and far between. So direct electric heating, it gets a bit of a bad press, because obviously in the past we've relied quite heavily on electricity coming from the grid. Obviously price of electricity per kilowatt hour is quite significantly more than gas. But for example, if you were to put solar on with some batteries, then direct electric heating could be a very, very viable option for you. Electric radiators are 100% efficient. So if you put 1 kilowatt in, you'll get 1 kilowatt out. If you are using them on the grids, so it will cost you the price of 1 kilowatt hour. So maybe if your energy provider is charging you 27 pence per kilowatt hour, then your radiator will cost you 27 pence per kilowatt hour. So that's something to be very mindful for. But they are easily regulated. All of them will have to comply with Lot 20 in the UK, so they do have to have a thermostatically controlled option on them. They generally will have lower installation costs than a wet system. It is just a fused spur that they need to be wired into. But depending on the type of electric radiator that you choose, it can be a very, very viable system, especially if your property is incredibly thermally efficient. On the downside, they have quite limited scalability for larger spaces. So they will come in set wattages. You'll get 500 watts, 750 watts, 1000 watts, 1250, 1500 and 2000, for example. So if you've got a larger room, you may need multiple radiators in there. Some radiators, electric radiators on the market, work on a dry element basis, so they can dry the air. Oil-filled radiators will be more similar to sort of a standard wet radiator system, but a dry system can lead to dry eyes. It can exacerbate allergies, and in some cases will leave marks on your walls, especially in a bedroom situation where you may be in the room with a radiator for 8, 9, 10 hours. You have to be quite mindful about the type of electric radiator that you're choosing, so that you don't make yourself uncomfortable during the night. And the other disadvantage is that they can only be used for heating, and you will need something else to generate your domestic hot water. There's a lot of talk about heat pumps and their performance. An air source heat pump, the COP is the coefficient of performance. So in sort of layman's terms, it's the energy that you put into it and how much is generated from that. So for example, a COP range of 2.5 means that you're putting for every kilowatt of energy you're putting into the heat pump, you're getting 2.5 kilowatts out of the heat pump. So it's actually generating more than you're putting in. And obviously, if you're getting 4 on a COP, you're putting 1 kilowatt in and getting 4 kilowatts back out of the heat pump system, which makes it very, very efficient. Much more efficient, say, than an electric radiator that is 1-to-1. There's different types of heat pump systems. Obviously, air source heat pumps are probably the most prevalent in the market. Ground source heat pumps, also very, very viable system, providing you've got space around your property in order to either install a brine loop or make some boreholes. Or there's water source heat pumps. So obviously the higher the COP is, lower running costs, reduced carbon emissions, you get a better return on your investment. And if you have a reversible heat pump, they can also offer you some chilled water in the summer, so you could have a cooling option from there. Gas boilers. There's been a lot of talk about gas boilers in the press, and how they are the worst thing ever to have existed. But actually, they're fast, powerful heating sources. It's a reliable, it's a well-established technology. Gas is much less expensive per kilowatt hour than electric or oil. They will offer you hot water on demand as well. They don't require an awful lot of plant space. They're quite easy to maintain. You get your boiler serviced quite simply. But obviously the disadvantages of that being that they do rely on fossil fuels. So they do contribute to our carbon emissions. They're not necessarily a future-proof solution. I would imagine that one day they will cease to exist. So if we're talking sort of 10 years down the line, will they still be able to be repaired and maintained? Will parts still be available? That's subject for debate at the moment. And obviously, if you're having to run a gas main to a property, then it will cost quite a lot of money. But if your budget allows for a gas boiler and that suits your property, then there's no reason at the moment why you shouldn't install a gas boiler. Solar thermal, not something that we see an awful lot in the UK. There's 3 main types for residential settings. We have flat plate collectors, evacuated tube collectors, and thermal air collectors. Some of them are less efficient in colder climates or low sunlight. We've had quite a lovely summer this year, but obviously that's not when we have our heating on. Our heating does tend to go on when it's not quite so pleasant outside. So the systems do rely quite heavily on sunlight. Those that are the most expensive will work better in cloudy or colder conditions, but obviously they're quite substantially pricey, and they're it's an investment basically. It's quite an expensive way of doing it, but they are there. They do exist. They are in the marketplace. I know some people that use them very successfully. But yeah, it's just an alternative option. If you've got a lot of roof space, you've got a planning authority that doesn't mind you having quite a lot of solar panels on there, then yes, you could use a solar thermal system. Thermal air collectors, however, will only offer you an air-based solution. So you would have to do all your heating through air, which can make it a little bit trickier. So we've decided how we're going to heat our property. We'll need to have a heat loss calculation done. If you were decided to go down the heat pump route, then a heat pump manufacturer will generally conduct a survey. They'll determine how much heating is required in each individual room. And this will vary from room to room based on floor area, building orientation, the fabric, how much solar gain that you're going to be getting, and that sort of thing. Underfloor heating versus radiators. Both are very effective ways of heating your home. It does come down to personal preference at the end of the day. One is not necessarily better than the other. I know that underfloor heating seems sort of almost synonymous with a heat pump system, but you can absolutely use radiators if you would prefer to. Underfloor heating obviously has its advantages, in so much that it's not taking up any of your wall space. It is slightly slower to heat up, but it will retain heat for a lot longer. Something to be mindful of is if you've got an incredibly thermally efficient property, that you don't overheat using underfloor heating, because once the concrete slab, the screed, is warm, it takes a long time to cool down, so it won't be that reactive. You will get a good EPC rating for using underfloor heating. It's not very fair, I don't think, because obviously if you're using a renewable system, that EPC rating should be pretty much the same for a radiator system if you're running at the same temperatures. But yes, you could get improved EPC ratings for underfloor, even if you do nothing else to your property apart from insulate and put in underfloor heating. Your EPC rating will improve on your property. Radiators will have a faster response time. You'll be able to turn them up and down. If your room is overheating or getting slightly too warm, it will respond a lot quicker than an underfloor system would do. They're easier to retrofit. You'll get more control room by room, and they can look really nice. They can make a real feature of your room. There's a couple of different types of underfloor heating. So there is obviously electric underfloor heating. Typically, we only see these in smaller spaces, so like bathrooms or en suites. They can be quite expensive to run, especially in comparison to water-fed systems. They're not as efficient for a whole house heating solution. But they do exist if you've got a small space, for example. And obviously, again, if you're using a solar system with a battery, then it could be viable for you to use electric underfloor, especially if your property is very thermally efficient. But the most common type is obviously a wet system. So they would be polypropylene pipe sunk into a screed or concrete layer with some pipe with some flooring over the top. Some of them will just be with a timber floor over the top. There's lots of different types of underfloor heating now. Obviously, lower running costs, especially with a heat pump system. So the wet systems are much more efficient for heating large areas of houses. Do have a slightly higher installation cost and some complexity. You do need to get an expert in to do that for you. And they can be slower to react, as I say, because of having to heat up a floor type or screed before it actually puts heat into your room. Lots of people think that radiators are possibly worse for the environment. Metal is a high carbon material. There's no way of getting around that. But actually, radiators are 99% recyclable. So that significantly reduces the CO2 impact, and especially at end of life, and contributes to a much more circular economy. Underfloor heating, on the other hand, cannot be recycled at end of life, so it is just going into landfill. And aluminium radiators are manufactured from recycled aluminium, so every time you pop a can into your green bin or blue bin or whatever your local authority's colour bin is for recycling, they generally get turned into radiators. So it's quite a fun fact, really. There's a lot of talk about low temperature radiators. What are they? Unfortunately, they're not magic. They don't come with a Harry Potter style wand. In many instances, they're no different to any other radiator. It's just that they will offer more heat output size for size than some other models, which makes them more suitable to use with heat pumps. The benefits of them are obviously they're very energy efficient. They're safe to touch. If you have small people or even elderly people whose skin is less dense than a standard adult, with the lower water temperatures means that the surface temperature of the radiator is a lot lower. So there's no need for sort of low temperature system, low surface temperature radiators. And obviously they're slightly better for the environment than using a standard boiler. Types of radiators for low temperature systems. We have fan assisted radiators. We would typically use these in a retrofit sort of scenario, where we're trying to increase the output because we've lowered the water temperatures by installing an air source heat pump, for example, but don't want to actually increase the physical size of the radiator. We have decorative radiators with larger surface areas. So obviously the larger the radiator, the more output you're going to get from it. We've got double tube towel warmers, so tubes on the front and the back, so that they will offer you that bit more output at lower water temperatures. And obviously radiators with a supporting heat source, dual fuel, so that you can actually use the radiator in the summer without having to have your entire heating system on. Fan assisted radiators. So they are in essence just a radiator with a little fan inside them. That fan increases the convection, so we'll push more air through the radiator, across the surface of the radiator, and warm that up, so it will be more efficient. They're really good for spaces that require fast heat up times, or you've got very limited space for a large radiator. If you have a reverse cycle air source heat pump or heat pump system that is reversible, you could use them in the summer for a sort of we call refresh option. So you could run cooler water through them, which would add some cooling benefit to the room. But we have to be very mindful of the fact that if it doesn't have a condensate drain installed on the radiator, we have to run them above dew point, because otherwise it will condense on the front of the radiator and start to drip on the floor. So some of them are manufactured with condensate drains on them, so you can do active cooling. So you could actively cool via the radiators in your room, but for the most part, they don't have condensate drains. The ones that do tend to be a little bit more industrial. So you would have to run the water temperature a little bit higher, and so the cooling potential from them is a little bit more limited. Radiators with large surface area. So we can make radiators bespoke to order. So we can make them taller, deeper from the wall, wider. They will offer you a large heat output. Some double panel radiators will have a relatively compact size, physical sort of dimension size, but could be quite deep from the wall. These are best for buildings that have got sort of moderate insulation and they have space for larger radiators. Obviously in sort of more heritage style buildings, where you couldn't necessarily pick up a floor because it might be listed, a sort of multi-column style radiator would be most suitable. You could use them for some refreshing effect above dew point during the summer months if you had a reverse heat pump, but it would be very limited. It would barely be noticeable, I would have thought. Aluminium radiators, they heat up very, very quickly. Perversely, they also cool down very quickly. So unlike a steel radiator, which will hold heat for some time after the heating has gone off, an aluminium radiator that heat will disperse from it very, very quickly. But because they respond so rapidly, it makes them brilliant for heat pump systems, especially if we're going to be using weather compensating. Heat pumps don't like to be turned off. They like to be cycling constantly. So what a lot of heat pump installers will do is that they will vary the flow temperature based on the external temperature that's going into the rooms. So, for example, it's slightly warmer today than it was yesterday, so the temperature of the water going into the radiators would be less today than it was yesterday, so that heat pump is still cycling and still working at its most efficient. If you're going to do that, then the fact that they cool down very quickly it becomes a non-issue, because they will constantly have water going through them at some temperature or another. They're brilliant because they do react so quickly. So, for example, if you've been on holiday, come home, you pop your heating on, you'll get heating very, very quickly from them, rather than having to wait around for your heating to warm up. As I mentioned, double tube towel rails, these provide increased heat output versus a standard ladder rail. In the UK, we tend to use towel warmers as our primary source of heating in bathrooms. It's not really what they're designed for. They're designed to warm towels. But if you go into 99.9% of the bathrooms throughout the UK, that towel warmer will be doing it's the heating on its own. So if we're working with lower water temperatures, then we will need a little bit more physical radiator in order to warm that space. So we've decided to put tubes on the front and the back, so that we're not increasing the physical size of the radiator, but we are increasing its output potential. We can also make these what we call dual fuel. So we install an electrical element as well as water. So in the winter months, when you've got your heating on, you can absolutely use it using the standard heating system. And then in the summer months, we can add an electric element into them, so that you don't have to put on the entire heating system just to warm up a towel. Another option is trench heating and cooling. This was typically quite a commercial type product. You tend to see it in foyers of buildings, in car showrooms and that sort of thing, but has made a real resurgence in the last year or two. It's basically a radiator that is sunk into the floor. So at ground level, all you see is a little grill. Very good in front of a sort of bifolding doors, large areas of glazing. Will do your heating and your cooling, will actively cool, so will offer you a significant amount of cooling, and it will cool the air before it actually comes in. So, for example, if you have a large expanse of glazing, say your building is south facing and the sun's coming in all day long, you will be getting solar gain through there. But the trench heating being right in front of that window will be cooling that air before it actually enters your property. One of its disadvantages is it's quite difficult to retrofit, because obviously you've got to dig a hole in the floor for it to sit into, and it will require a condensate drain, and it will require a power source to it, because it has a fan within it. What it does is it draws air in from the room. That air is passed over the emitter, which will either get warmed or chilled, depending on which season you're in, and then pushed back into the room via the fan. So it will need power to it as well. Something that we don't use very often in the UK in a residential setting, it's seen much more often in a commercial setting in the UK, is radiant heating and cooling. So these are active ceilings that we can put either hot or chilled water through, which will offer heating and cooling, but from above. It's quite an alien concept to a lot of people. The best analogy that I have for a radiant system when in heating is if you imagine yourself out on the beach and it's a sunny day, the sun's out, you feel quite warm. But as soon as the sun goes behind a cloud, you start to feel cooler. And that's because you're receiving less radiant input. It's not because the air temperature around you has changed in any way, shape or form. The sun is radiant in its purest form. it travels 93 million miles through space. And the first time that we feel that is when it interacts with us, it touches our skin and we feel warm. So radiant systems work in a very similar way to that. We can use them for cooling. It does have to be above dew point, I'm afraid. Otherwise, it condenses on the ceiling and then rains on everybody, which makes you slightly unpopular. And especially in an office situation, if it rains on people's computers, it makes you incredibly unpopular. But yes, so absolutely, radiant systems, not very prevalent in the UK, but are used all the time by our Italian colleagues. It is an option if you wanted underfloor, but obviously in the ceiling. Much easier to repair. If something was to go wrong, it's easier to take out a panel from the ceiling than it is to dig up your floor. So radiant systems are quite cool. That's one of my favorites. And Comfo Post. So this is a water battery. So it's in essence a radiator in a box. This is fitted to the supply side of your MVHR system and connected obviously to a heat pump or heat source. Obviously, if you would need a reverse heat pump if you would wanted to use it for cooling as well. It's just a fin emitter. So it's just a radiator in a box in essence. It's no more complicated than that. The MVHR acts as the fan, so it pushes air through the box, and the hot water or the chilled water will dictate whether that air is being warmed or if it's being cooled before it's pushed into your habitable rooms. It's very compact. It's hidden from view. It's typically either sunk into the ceiling or it's next to your MVHR unit. But the disadvantages of this is it is a whole house solution. So if it's in heating mode, it is heating all of the rooms that are attached to the supply ducting, and obviously the reverse, if it's cooling all of the rooms that are attached to the supply ducting. So it's not controllable room by room. You can't say I'd like 12 degrees in this room and 18 in the next. It's either all or nothing. So in summary, the choice of hot water generation method, whether traditional boilers, heat pumps, solar thermal systems or electric, depends on a range of factors, including property type. Obviously, if it's easier for you to put solar panels on your property and use a fully electric system, then by all means do so. It depends on your energy efficiency goals. Some people are more conscious about the amount of carbon that they're using than others. Obviously, installation costs is a huge factor, and your long-term sustainability. So each system does offer unique benefits and challenges, but understanding these helps you make much more informed decisions that align both with maybe your environmental targets and your needs, because ultimately it's to make you comfortable, and it's a real investment. You're putting your time, your money, your energy into producing your forever home, so it's got to meet your needs as well. But combining the right products with the right heating strategy can enhance your comfort, reduce your energy consumption, and support your transition to low carbon living. Obviously, none of us want to spend an awful lot of money on any sort of heating or running their property. The cost of living is increasing day by day. So if we can reduce that, then all the better. And if anybody would like some further information or wanted to get hold of me, here are my contact details. Please feel free to drop me a line or give me a little call and we can have a chat about it. And that's me. I think we're on to questions now, if we have any questions.
That's lovely. Thank you very much, Louise. That was really, really useful to give an overview and talk about some of those heating systems that many people aren't familiar with, or or maybe have heard about but don't understand how they could be implemented in a residential setting or in their own setting. I also appreciated some of the conversation about radiators. It seems like everyone is really trying to go away from those. However, there are some instances where it makes much more sense to think about the use of radiators, especially if you're altering a property versus doing a new build. So.
Yeah, I mean, if you've got pipework pre-installed, then it can be much more cost effective to just install radiators. By changing your radiators alone, you can increase their output by 30%. This is due to, contrary to manufacturers' recommendations, nobody gets their system power flushed every 5 or 6 years as they're supposed to. So you do get a build-up of silt and sort of a small ecosystem living in the bottom of your radiator, which obviously takes up space where hot water could be sitting. So you're reducing their output potential by not power flushing them. But if you're living in a property that you're not intending to stay in and they haven't been power flushed for 30 years, I would not power flush them now, because that may open a can of worms for you that you're not willing to deal with. Yeah, so power flushing radiators will keep them running much more efficiently than they were before.
Well, that's a really good point, because we didn't talk much about maintenance. If someone is sort of moving into a property that's new to them and they've got radiators in the house, they have no idea whether they have been, is that something that someone such as yourselves or a different a maintenance company could come in and you sort of understand whether it was sensible to power flush or whether it had been too long?
Yeah, I mean, the integrity obviously of the radiators would break down over time. But I mean, radiators last a very long time. People will have radiators for 30 plus years in their properties. So it would be best to get somebody out to have a look and assess the radiators as they stand. They should be able to tell, judging around the sort of air vent area and that sort of thing, if there's been an awful lot of corrosion. A lot of systems aren't maintained as correctly as they should. They should be topped up regularly with some inhibitor and that sort of thing. So yeah, I would have somebody come and look before you just gung-ho and book a power flush, because it could mean that the radiators all go pop and then you've got a real big issue.
Yeah. Then you'll have your more efficient radiators coming in behind them, I suppose. And relative to other systems like underfloor heating, what are the maintenance requirements for those? Do those have a power flush that should be done? And then water source, obviously.
I think it does depend on the manufacturer's recommendations, but I would assume that yes, they would be some system maintenance. They obviously go through a manifold, so it would be slightly different to a radiator system. But each manufacturer will have a recommendation based on, every 5 years or every 10 years to get them serviced and maintained.
Okay. And you did talk about sort of the typical life expectancy of radiators, that a lot of them last 30 years. How about some of the other systems? Do those have the same longevity? People often have some concerns about underfloor heating because they think, oh, what if something goes wrong? Then I'm going to have to rip out my floor. How common is that? What would you have to replace if you needed to replace anything typically?
Obviously, us as manufacturers, we've been going through a process of what we call environmental product declarations. It's something that a lot of the industry are asking for. So we do have to put a figure on how long we expect the life expectancy of a product to be. Obviously for the carbon credits and to work out how long that they might be in existence before they go to end of life. Underfloor heating will have a lifespan, or an expected lifespan. Obviously, they're plastic, so I wouldn't expect them to degrade very quickly. As we all know, plastics in the sea and things like that, they don't tend to disappear very quickly. We're not underfloor heating manufacturers ourselves, so I don't have any sort of firm information on that, but they will have an idea of how long that they expect it to last. And it's a good question to ask a manufacturer: how long are you guaranteeing this for? How long do you expect it to last? And what might be the pitfalls of it? I don't expect, unless you're drilling into your floor, that perforation would be an issue, I don't think. So once it's set, but you could get a blockage, for example, which might be difficult to get out. They're questions worth asking a manufacturer when you're purchasing something like that.
Lovely. And can you mix and match some of these systems that we've been talking about?
Absolutely. If you wanted underfloor heating on the ground floor, but then radiators in the bedroom, absolutely you can. I think that's the way that lots of people do go. I know of people who've got radiant systems on the ground floor and then radiators above, because then all the services are pretty much running in parallel. The radiators are being fed from below, the radiant system's fed from above. So yeah, absolutely, you can mix and match.
And how would someone go about when would they contact someone like you to start thinking about the design of their system? How would they approach you? Would you automatically do that heat loss calculation as part of your service, or is that a separate service that someone could offer for them? How does the process usually look?
We do have a heat loss calculation tool on our website. So you can go in there and run a heat loss calculation based on the room per room. But it is generally the provider of the heat source that would do a heat loss calculation for you. So for example, if you'd chosen to go down the air source heat pump route, the air source heat pump manufacturer would come out and do a survey, and they would work out how much was required per room. And then you can make your decision based on, I'd like underfloor, or I'd like radiators, or I'd like something like that. And then we size the radiators to meet that requirement.
I see. Yeah, no, that makes sense. And you've got here at the NSBRC, where I'm standing right now, you've got a stand there. So a lot of these systems that people may not be familiar with, they can see them in person, to just see what it looks like beyond the images that you've shown with us.
Yeah, so we've got a range of radiators on display. There is some trench heating there as well, so you can get an idea of what the grills look like. They do come in lots of different finishes to match floor surfaces. We've got mechanical heat recovery on display there. There are some fan assisted products as well as some standard radiators, obviously the Charleston, because it's kind of our baby, but they're also there. Along with a fan assisted towel warmer as well. So
okay. Yeah, that's excellent, because I think sometimes people just have trouble visualizing how they might look in a space on a wall, and that is really useful to be able to, I always encourage people to go out and visit manufacturer showrooms, that sort of thing. So that could be a really good way just to get started on what do you like the aesthetic of, beyond performance. What are the things you want to incorporate into your house, and then see if you can match that up with the performance requirements.
Yeah, I mean, radiators are a bit like a fire. The minute you see a radiator in a room, you already have the sort of mental or subconscious thought that it's warm. So yeah, it's one of those strange things. But yeah, I mean, obviously I work for a radiator manufacturer, so I'm a little bit biased, but I've seen some beautiful radiators, and a lot of them can be bespoke, so you can put them into bay windows, so double angle bay windows, or a curve, for example, round pillars, so they can be a real feature as well as functional.
There is a question that's just come in on cooling a room and condensation. So the question is, on cooling for a room to say 26 degrees, what would the temperature for the radiator, what would a radiator be at to be above dew point?
Sort of between 16 and 18 degrees typically. Dew point will obviously lower the cooler that the room is. It will get lower and lower, but unlike a sort of commercial setting where we don't have like washing or people boiling water or running a kettle or having a shower and that sort of thing, where we can have the water temperature slightly lower. So if 16 would be the lowest, I think, the water temperature going into the radiators. I have an environmental meter here that's measuring my dew point because I've been doing it for a year now, because that's just the sort of person that I am. But yes, sort of between 16 and 18 degrees typically to be above dew point comfortably.
Okay, thank you. There's a question that goes back to your early slide where you talked about insulation always being the cheapest form of heating. So the question is if whether installing an air source heat pump or really any sort of heat pump in an older leaky property is worth it, or would they be better in investing in insulation and airtightness? Where's that balance?
I think in a leaky property, however you choose to heat it is going to be more costly than in an energy efficient property. My viewpoint is fabric first. So make the need or the requirement for heating less to start with, and then when you actually come to heat the property, you'll need less, it will use less energy. So fabric first is always the best approach, especially if you're going to swap from a gas boiler to an air source heat pump without doing any remedial work on your property, because the gas per kilowatt hour is what, it's about 7 pence per kilowatt hour, whereas electricity we're in the high 20s of pences per kilowatt hour. So to achieve the same level of comfort, you're going to be using an awful lot more electricity, unless of course you've got solar panels, but it's still going to be more costly at the moment without doing anything to your property to use an air source heat pump than it is to stay where you are. So fabric would be my first approach. Stop all that air getting in, and then decide next what will be your next step. But obviously if you're sealing up the building, you will need to ventilate, because you will get mold and condensation if you're not careful. So whether that be wind trickle vents and extract fans, whether that be some sort of mechanical ventilation system or heat recovery, ventilation is key, because black mold does contain carcinogens. It's not good for you.
Yeah, and along those same lines, I mean, if you are thinking of improving the thermal efficiency of your existing house, condensation risk is a really important factor to consider. Not all insulations are equal. Not all insulations should be put in certain applications. So it's really important to deal with a professional who understands what that detailing should look like, ideally, in order to get the best performance out of it, and then pair that with a ventilation system to deal with all of the fresh air and condensation appropriately. And I think, just looking at sort of the mandate to move away from fossil fuels, we're probably looking at a future where gas will not always be 7 pence per kilowatt hour. And
Yeah.
and if you're suddenly realizing that you have to switch to an electric system and you do have an old leaky house, you're going to be paying way more than you currently are for that same heating.
Yeah, I mean, for my money, I would go for a heat pump. If I was building my own house now, it's not worth in the house that I live in, because it's not thermally efficient enough. It needs too much doing to it in order to make it thermally efficient enough to warrant a heat pump. I would be moving towards the renewables energy sources, because it future proofs your property.
Right. Yeah. Okay. Well, thank you very much, Louise. I think we've come to the end of our Q&A session. That was really extremely helpful. And we will be sending out at the end of this your contact details, but likewise, this presentation is going to be posted on our website so people can watch it on demand later. So please, anyone who's listening to this and would like more information, you can contact Louise. You can also come to the NSBRC and visit their stand here. And I'm just going to close with a few of the top takeaways that I've put together. So top takeaways that I've put together is that, and this is one that's very dear to me, is insulation is always the cheapest form of heating, and going for that fabric first approach. A heat loss calculation will be required to understand your heating demand. And that heat loss calculation is very specific to your property and the fabric of the property, and even the massing, the way the building is shaped. Underfloor heaters and radiators are both options with a heat pump system. You should consider the type of year that you'll be using your radiator in order to select the best specification if you're going for that sort of system. And then finally, it's important to maybe consider alternative heating systems for bespoke installations, or just even looking at the future of the systems that are there. So thank you very much, Louise. Really appreciated your talk and your time today, and I'm sure everyone out there listening appreciated the insights that you provided for us.
Thank you very much for having me.
You're very welcome. So there are a few places that you can see ourselves and Zender and people like Louise. We've got the Home Building and Renovation Show in London coming up. That's next weekend, the 19th to 21st of September. Louise, will Zender be at that?
I don't think so, no.
Okay.
I don't think we've got any plans to exhibit there, no.
Okay. No problem at all. But there is the NSBRC Autumn Show also coming up. That is here at the NSBRC in Swindon. That's just 2 weeks later, the 10th and 11th of October. So please do come ask your questions in person and see some of the products. That can always be a really helpful next step in your self-build or your renovation. As a reminder, next month, we'll be back here again. Same day, second Thursday of the month, and same time at 1 o'clock. We'll be joined by Mark Miller. You probably do know him as a TV presenter and a DIY expert, and he's really going to be talking about what things you can DIY, what information do you need to know, where should you be a bit cautious, and what are the resources for you. So I think that's something that anyone embarking on self-build will be very interested in. So we do look forward to seeing you again next month. Have a lovely month. Good luck with your self-build, and please do be in touch if you need anything.